Hey, thanks for coming. All right, so we're gonna do a few limiting reactant problems just to get some more confidence with these. So let's do this first one together. All right, so what I'm gonna invite you to do is to pause your video and just read the problem carefully. And on your paper, your first objective is to write the balanced chemical equation, right? So we can't do anything in stoichiometry unless we have the equation. So make sure it's balanced. Assign the mass values to each of the reactants, and then once you've got that much, then you can restart the video. Okay, go ahead. Okay, so hopefully you guys wrote down that oxygen, O2, is reacting with hydrogen to form water. Okay, and then to balance it, you just need a 2 in front of the hydrogen and a 2 in front of the water, and you're all set. And hopefully you assigned 1.22 grams to the oxygen and 1.05 grams to the hydrogen. Now, in this problem, so we call it a limiting reactant problem, and the reason this is kind of a special variety of stoichiometry problems is you're being given the amount of two reactants, and oftentimes you're being asked to calculate how much product you can make. Now, I realize in this problem, the way it's worded, it's only asking you to figure out which one's limiting, but I'm going to ask that we take it a step further, and once we've determined the limiting reactant, we then calculate how much product we can make. Okay, so there's like a couple steps involved. So step one is to, I'll put a little 1 here, is to determine the number of grams of hydrogen needed to fully react with 1.22 grams of oxygen. Okay, pardon the writing here. This looks like a kindergartner, but I'm doing my best with my graphics pad here. Okay, so that's the task. Is we're going to take the amount of the first reactant, and we're going to ask the question, how much of the second reactant would we need to completely consume 1.22 grams of oxygen. All right, so to do that, we're going to set up a mass-to-mass stoichiometry problem. So we take 1.22 grams of the oxygen, all right, put that over 1, and then we're going to do a 3-step conversion. Okay, so the first thing we got to do is we got to put the grams of oxygen into moles of oxygen. Okay, so that's 1 mole over 32 grams of oxygen. Okay, so that's our mass to mole conversion. Then to get from oxygen to hydrogen, we're going to need, it's a 1 to 2 mole ratio. So now that we're in moles, we're going to do our mole conversion. So that's 2 moles of hydrogen over 1 mole of oxygen on the bottom. All right, and then you can see that moles of oxygen cancels out. And then now that we're in moles of hydrogen, now we're going to convert moles back into grams. So the molar mass of H2 is 2.0 grams over 1 mole. Okay, and when we do out this math, what you're going to hopefully come up with is 0.15 grams of hydrogen. Okay, so that's how much hydrogen would actually be needed to completely react with the 1.22 grams of oxygen. So now look at what they gave us. They gave us 1.05 grams, which is way more than what we actually need. So the hydrogen is in excess. So I'm going to put an excess there, and if hydrogen is in excess, then oxygen has to be limiting. Okay. So now in step 2, when we go to the next slide, we're going to base the amount of water that can be made on the limiting reactant, which is oxygen. Okay, so here I would like you to pause your video and I want you to try to set up that calculation where you take the 1.22 grams of oxygen and convert that to grams of water. So go right ahead. Okay, so hopefully you guys are doing okay. So that's so the mass of water that can be made, we set that up by taking 1.22 grams of oxygen. Put that over 1, and then we're going to convert that to moles, and then we're going to do the mole to mole conversion between oxygen and water, and then we're going to convert that to grams of water. All right, so that's 1 mole over 32 grams, and then that's going to be 2 moles of H2O over 1 mole of oxygen. And we're going to multiply that by the molar mass of water, which is 18 grams. Okay. All right, so hopefully your setup looks something like this. And when all the dust settles, you should come up with 1.27 grams of water. Oops. Okay. And I'm sure your writing's going to look a lot better than mine. But at least, you know, sometimes it helps to do this with a partner. Okay. So I will see you on the next video for the next problem.